All right. Hello, everybody. I put a message in the chat in just to acknowledge that about the poll before I give my little spiel here. I guess, Mr. Ramirez, what would you say to that question? Are we asking the type of renewable energy that's cleanest while operating, or the full life cycle?
You need to consider the carbon footprint for that.
Okay. All right, that's what you get. That's the only hint you get. But fill that out, please, and I'll close it before the presentation begins here. But hello, everybody. My name is Clayton Markham, and I'm a junior environmental engineering major here at the University at Buffalo. Last year, I started and led the UB ESW team in the Solar District Cup, which is a new competition founded by the US Department of Energy, challenging students to design a solar plus storage energy system for a given client. And that makes me especially excited to be moderating this session, Double Energy Input. Good morning to our speaker today, Mr. Daniel Ramirez. He is coming to us live from Auckland, New Zealand, and I believe it's 10 in the morning where you are, correct?
Yes.
So thank you for getting up for us. Mr. Ramirez was born in San Luis Potosi,
San Luis Potosí, Mexico.
Okay.
Yeah.
Thank you. Out of practice. In 2017, he moved with his wife and daughter to New Zealand. And there he enrolled in a Master of Energy program at the University of Auckland. During the Masters, he invented a power generation model, which I'm sure he'll talk to you about today, based on gravity and hydroelectric use and geothermal energy. He was awarded the Best Thesis Award at the Faculty of Engineering at the University of Auckland and graduated with honors. In November last year, he exhibited his invention at the 42nd Geothermal Convention at the Bay of Islands in New Zealand. We are so honored to have him here with us this evening, morning, depending on where you are. Please hold your questions for the end. Mr. Ramirez has notified me that he will be taking questions, reading them directly himself through the chat. At the end, we'll just jump right into Q&A. So without further ado, Mr. Daniel Ramirez.
Thank you so much. Do we have the result of the polls? Let me see. No, I cannot see them. Okay, let's start. I want to start my presentation, bringing the PDF and talking a little bit about the experience of this adventure. Double energy input. As Clayton said, this invention has two inputs. We live in an era of inefficient, expensive, dirty, and dangerous energy. And we can see the pollution, we can see people sick, we can see all the nature going into a disaster. Why? Because we are taking all the resources of the planets and making a very bad administration of them. We put on the environment, we don't end all the cycles, and we gather energy from the wrong sources. The oil process is expensive and inefficient, totally inefficient. We got a lot of pollution. We spend a lot of energy taking the oil from the ground to processing the oil. And it's the same with the coal. We put a lot of carbon in our atmosphere. We trigger the effect of the global warming, and we don't take care about the planet. The dirty energy, the problem is that it's very inefficient and it has a lot of steps. Most of them, you cannot take control of them. Let's see what is this. First of all, we need a geological formation of the commodity. In the case of oil, gas, coal, we know them as a fossil fuels. Then living stock die, and they are under the ground. A lot of pressure, a lot of high temperatures produce that rest of the living stock become carbon, oil, or gas. But it requires millions of years and several conditions like pressure, heat, and geological formations. And we are pricing in a wrong way that resources because they are limited. We are pricing them as the market says. But if we consider all the million of years that it takes to have 1 barrel of oil, the price could be like a lot of money, not the $60, is $100 that we are paying for that. Then we need to extract the commodity, and we need energy for that. We dig a hole, we find the resource, and with the pressure underground, we get the oil. But after that, in the case of the oil, we need to refine because it's not pure, and each oil is different, and we need to put into a refinery process. We waste energy in the first and the second step. After that, we need to construct the power plant for oil, gas, and coal. And we take resources and energy. Then we transport to the power plant, and we need more energy because we put on pipes or in big trucks all the oil or all the gas or the coal, and we bring into the power plant, and that takes energy. And that after that, we need to transform the commodity to heat, and that produces pollution, that produces um, carbon dioxide in our atmosphere and other pollutants. And the problem is that we are losing energy changing this commodity to heat. After that, we change that commodity from heat to mechanical power. We waste more energy. That is inefficient. And at the end, we change the mechanical energy to electrical energy, and we are wasting more energy in that process. It's the same from oil, gas, and coal. Gas and coal don't need to be refined in a refinery, but anyway, that all the other steps are there. In the case of renewables, they tend to be cheaper. Why? Because we have less steps, and they are more efficient. Sun, wind, water, and geological heat, they're interacting with us in a constant basis. We don't need to wait millions of years to have a process to receive the solar beam, to receive the wind power, to get the water and put the dam and take the energy. And in the case of geological heat, we need to dig, but the geological heat is everywhere in this planet. We don't need to extract the commodity as a first step. Only the case of geothermal heat, we need to dig a hole and take the geothermal heat or the water. We don't need to make any refination process. We need to construct a power plant. We don't need to transport the commodity to the power plant because if we have solar panels, the sun comes by himself, the wind comes to the windmills, and we don't need to transport anything. Change it from the commodity to heat, we don't need to check anything. In the case of geothermal, we have hot water, and the hot water is already heated. And you lose some energy changing from heat to mechanical, and you lose some energy to change from mechanical to electrical. Maybe the less inefficient process or the most efficient process is the solar power because it comes directly from photovoltaic power, and you transform it into electrical power. What is DEI? This idea comes several years ago about thinking how can we use the gravity to have more energy. And I looked into the dams, I looked into another ways, but I was thinking there can be another way. And this is the double energy input is a hybrid between hydroelectrical and geothermal power plant. We are taking an advantage of the seawater and the difference of height between the sea and the place that we will allocate our water. And if we dig a hole, as you can see in the diagram, that hole will we have geothermal heat. This is double energy input open pit model. For this, we require a pit with a 3 kilometers of depth. That is very deep. And an area at the bottom of the pit about 3.5 square kilometers. We need a big pit in order to have an advantage in this invention. Oh, sorry, I don't know what happened.
I'm not sure. I would just bring your presentation back up. Just keep going.
Okay.
And the results, whenever you want them for the poll, let me know. They're there.
Maybe we can talk about the results.
Yeah, just 3 people took it, but they were all for wind. Everyone said wind.
Okay. I have the information that the cleanest, considering only the carbon footprint, is a nuclear plant, and we need to discuss why we don't take the nuclear power plant, because it's cheap, it's clean, it's efficient, but we have the nuclear waste. That is not considered into the carbon footprint. But anyway, this invention tries to make a power plant as big as a medium-sized nuclear power plant, without taking all the risk and trying to be cheap and trying to be clean as possible. Well, let's continue. The other part of this invention is a reverse osmosis filter. We are dealing with water from the sea. The water of the sea is salty and it's very corrosive. Then we need a filter to clean up the water. The filtering process is very expensive in terms of energy and money. Then you need to put a lot of pumps to make the pressure works and pass the water through the filters, and then it will be fresh water and clean. But in this case, because we will be allocating that filter about minus 900 meters below the sea level, the pressure by itself is about 8 megapascals, and that allows us to filter the water without adding any more pressure. That is what this step is useful for us. But we cannot filter all the water. That will be almost impossible. We need some water to filter in order to clean up our turbines. You will see in the next. We will having 3 Pelton turbines at the time running at 75 cubic meters per second. That will be producing 1,200 megawatts of energy. That's a lot of energy, but that is also a lot of water. Then the 4th Pelton turbine that you are seeing there in this diagram 4 we will be cleaning that turbine, because otherwise the corrosion will destroy them. We require 4 Pelton turbines running at minus 1,800 meters of depth. Each one will handle 25 cubic meters of water per second and will be producing 400 megawatts of energy each one. Well, what we can do with a lot of water, as I told you before, we will have only 3 turbines running at the same time, because we require one of them being clean with the fresh water. And that process will stop to run one of the turbines. We will be cleaning, and we will be changing the turbine to another one and another one, and we need to clean up all the turbines in order to get less corrosion. Well, We have a lot of water. 75 cubic meters is like a small river. It's a lot of water. This process is very efficient. If you see, the Pelton turbines are one of the most incredible human inventions, and they work with a very high altitude, and produce a lot of energy with less water than a regular dam. But you need a very, very high altitude for doing that. After that, anyway, you will have a lot of water, and that water you need to rid of that water. Otherwise, you will not have a running power plant for that much time. We expect temperatures of about 200 Celsius degrees at the bottom of the pit, because it will be allocated at minus 3,000 meters. At the bottom of the pit, with these temperatures, we can rid of the water or produce more energy, or both of them. We need to allocate several and bury several tanks of 5,000 cubic meters of water to put the water on there, and the water that we cannot allocate in these tanks, we need to put into the bottom of the pit and expect that it will evaporate with the high temperatures. But putting water in these tanks will help us to produce more energy. Let me tell you how. We will fill these tanks and we will add more pressure. Like at the end of the process, we add the pressure of the beginning of the column, and we add pressure to these tanks. The pressure will be 32 or more megapascals, and after that, the water at this time will be not hot. It will be cold, but it comes from the sea, but with a lot of pressure. After that, we will be adding from 160 to 180 Celsius of geothermal heat, because the tanks are buried and they are interacting with the heat, with the geothermal heat. That will be add more pressure to our tanks. And we will have a concept that we call a supercharged water. That is water that cannot be boiled because they are in the same volume, but it's very powerful. It has a lot of energy for the pressure that we added, 32 megapascals, plus the heat, and we will be reaching more than 40 megapascals of pressure. When we release that supercharged water, we will be producing additional steam power. This part is similar to a thermal power plant, like a nuclear power plant. You heat water and you change it to mechanical, and you produce energy. It's the same as the oil and gas and coal power plants. You heat water and you have mechanical, and you run the turbines and you produce energy. But in this case, we are heating this water with the geothermal heat, and we are adding also the pressure. After we release, we get more energy, and with that, our model is about to produce 2 gigawatts of energy, 1,200 megawatts from the hydroelectrical phase, and 800 megawatts from the geothermal process. The economics is a big investment. It's about $2 billion. Why? Because making a pit hole of that dimensions is expensive. Even if we use explosives, that it is not that good, because they release a lot of pollutants to the atmosphere. It's expensive. The Pelton turbines, the reverse osmosis filters, tubes and cables, all the stuff is about $2 billion. But the revenues are interesting. We will producing about 2 gigawatts of clean energy, salt approximately like 2 tons of salt per second, and you can think that is a waste. No, if you sell that salt in the California market or the Canada market, you will be having more than $100 per ton of salt. That is even more expensive that the price that the price that you are paying for a 1 ton of coal. The brown coal is about $60. Why is that the salt is that expensive? Because they use on Canada, they use on the north part of the US to clean up the highways on winter, and they need a lots of salt to put on the highways and to bring safety to the drivers in the hard winters that you have over there. Other resources are the minerals that you will gather from making that huge pit hole. And if you can capture the steam at the ground level, you will be having fresh water. That is possible because you will having a lot of pressure at the bottom of the pit, and the steam that will be produced after the geothermal process, you can capture at the ground level, and you can turn it into the fresh water. This project requires further investigation. We need a complete breakdown of the project that shall be according to the place that it will be produced. I didn't talk about the place. The idea place for this model is I was thinking in Guaymas, Sonora, Mexico, because it's a very big desert, and you don't have a lot of humidity. You have a lot of sun radiation, and it will help to release all the water that you cannot put into your thermal power plant, to release into the environment without any kind of problem. And it's close to the US, and it has geothermal heat. A lot of geothermal heat. Is one of the places in Mexico that has a lot of geothermal heat. It is close to the sea. You have the sea just aside, and you have railroads, and that allows you to bring the salt to the US market for a very cheap price. But anyway, any place that is close to a shore and have geothermal heat, this model can be duplicated. We need a business plan. Investors, obviously. We are working into a boring model, not an upper air mining, because we want to make this cheaper and making the less damage to the environment. We are thinking about to make tunneling underground, and bringing the water, adding some pressure in pipes, and then release the steam and produce more energy, but without making a construction of that big pit model. We will have always in place challenges, and we need for this to make a simulation. A simulation is very important because we have the theory, but we need to add several stuff like the corrosion, like the time that the turbines shall be cleaned, the amount of fresh water that we can have per second is very useful for having all the things well planned. Conclusions. Having more renewables will bring us cheaper energy. Cheaper energy shall make cheaper processes. With cheaper processes, we may recycle more, run more cleaning processes as cleaning the water, cleaning the soil, cleaning the air, give to the final user cheaper energy or cheaper electricity for their processes, housing, industry, and commerce. And with this invention, allocating into the desert of Sonora, into a desert, we can bring water for the food production in hard places as the desert. Then we will be giving to the society a renewable and sustainable concept for making cheap and clean energy. Thank you so much. I hope you enjoyed this presentation, and I think it's now time for the questions and answers. Thank you so much. Do we have Do we have here?
So yeah, like I said earlier, just put questions in the chat if you have them. Um, I could get us started with one, perhaps. I'm curious. Do you see applications for this in New Zealand anywhere?
Yes, yes. New Zealand is part of the Ring of Fire, of the Pacific Ring of Fire. We have a lot of volcanoes and volcano activity. New Zealand has a lot of geothermal potential and geothermal power plants. Actually, this master that I have is specialized in geothermal energy. But the challenge in New Zealand is that here we have a very large amount of rain every year. And in this case, the rain is not helpful because we need to rid of from water at the bottom of a big pit. And then if you have more water, you are wasting your time and your resources. For New Zealand, I think it's better a boring model in tubes rather than building a open pit. In the case of Mexico, it's easier because they have mining in the Sonora state in Guaymas. They have all the resources for doing that. Uh, opening a pit of 3 square kilometers in a place in a desert is less dangerous than opening a pit in a place with a lot of vegetation, with a lot of livestock, with a lot of natural resources. But yes, New Zealand has a lot of potential. That's why they were interested in this project.
Very interesting. It seems like you put a lot of emphasis on the additional benefits, not just where is it cheaper, we're going to have positive secondary impacts, which I can appreciate.
Yes, but because if we consider, we can have is why we made the poll um, about the energy, because if we consider only the cheap and the clean of the model, we can think about nuclear power plant and that's it. We only need to rid of the nuclear waste and make a very good place like for 10,000 years to preserve all the nuclear waste. But we need to think into additional benefits, not only the carbon footprint is very important, the efficiency is very important, but we need, my philosophy is we need to complete the processes that we are opening. As for example, we eat food, but we waste a lot of food. That food we put into a landfill, and for us, it's okay. Yeah, we finish the process. No, we can do more with the circular economies. We can the recycling is good, but only 10%, 20% of the stuff that we have all the day is allowed to be processed as the recycle. It's not only the people putting the waste in the correct bins. No, we need to think to reuse. It's not only one solution. We need to think in about in more and more solutions. This is the example that the Israeli government give us in the problems. If they have one problem and there are 7 or 10 solutions, they put all of them running. And this is the example of the water. They produce food in the desert. They have a lot of strategies for doing that. And in the same way, that was the strategy of the New Zealand government with the COVID. They spot the emergency. They see the solutions of the Asian countries, the European countries, and the US countries, the American countries, and they put all the possible solutions in on the table, and they run the solutions. And now we don't have COVID for like a 1.5 year. We are free to go everywhere.
I've heard that about New Zealand. I'm a little jealous.
Yes.
Yeah, that's wonderful.
But at the end, in our day to day and in the how can I say, in our processes of living is not only making partial solutions. We need to think in a lot of. We need to feed more people. We need to feed it in a sustainable way. We need to produce energy, clean energy, cheap energy. We need to have our strategies and end the processes. Our processes of food or waste will end when we are sure that that waste is again in the cycle of the nature. At the same way, when we die, when the worms eat us, and we are part of again of the plants and the soil, that is the ending of the cycle. And when we consider energy, using oil, gas, and coal is only taking a very small part of the problem. We are only generating more energy. It's useful. We need more energy. Our society it requires that, but we are not ending any cycle. We are start running on other cycle, like putting more carbon on the atmosphere, like wasting a lot of energy, bringing the commodity, and etc. We need to think smarter, think more in a more strategic way.
Yeah, yeah. Very, very interesting. We have a question. And are you able to read that yourself in the Q&A section?
Sorry.
No,
Do
that's
you,
fine. That's fine.
do you have an
I
approximate carbon footprint cost for the construction of this project? And if so, do you know how many years it will take to become carbon positive once completed? No, I don't have that. We need a simulation, and in the simulation we need to consider that, Charlotte. Thank you for your question. Uh, in the idealization of this project is very important to think in all this stuff. That's why after I present the open pit model, I was thinking I am not happy with the amount of carbon that will be having for making that big pit hole, and that's why I start to work in the boring model. It's different tunneling. Tunneling is less pollutant than making a big pit hole, and we are against the open pit mining because it's very pollutive, and I need to present an evolution of this project that doesn't require an open pit. But yes, we have to 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 give a number, an approximation of the carbon footprint cost that we will be having with this project. If you have any other question, I'm happy to answer.
I guess I could ask another one and to give others time in case they have one. But I guess when do you see this system coming online? How soon do you think we can see systems like this? Are there unanswered questions that need to be answered before that happens?
Yes, I hope soon. And not because I want to make a business for this. That is good. That is positive. But if there is more ideas, more efficient than my idea, more efficient than this thing that I am presenting, I will be happy for that. If they can reach the fission power plant, no, the fusion power plant that they are willing to take, I will be happy that this project will be obsolete, because that promise that they give a lot of clean energy for the humankind. I have another question here. I hope I can. I am not able to tell you when this will be running, because this is new. I presented for the first time the last year. Now I put I put the patent registration here in New Zealand, and in Mexico. I need to do that in the US. Anyway, I need to talk with investors to make sure that the things are going well. But that this is an idea, and it's working. I have
Wonderful.
another.
Yeah, we got a few more in the Q&A, so I'll get out of the way here.
Awesome. Charlotte. Okay, no. Well, let me see the Sarah's question. Are there other key opportunities to combine energy sources to be more efficient, like floating solar over the hydro reservoir? But yes. I think if we're open to make an thinking on this, I think this is a good idea because if you put in floating solar panels and into a dam, you will be having two benefits. One of them is producing more energy, and the other one is to have less water loss from solar radiation, and you will be having more water for the hydroelectrical system. I like that. Yes, thinking out of the box is good. We have a lot of ideas that they are already working, but I like this idea. Let me see the Charlotte one. How does the project energy output for this project compare to alternative renewable resources? After we get a realistic and final carbon footprint, I wish that this project will be between the the carbon footprint for between the wind and the hydroelectrical, cleaner than the hydroelectrical, but I don't think that will be cleaner than the wind power. But talking about the alternatives and the options, I was thinking that in an open pit model in the desert, we can also in the space. Let me show you. In the space that we have for free, that we are not using, not putting water, not putting machines on there, it will be a lot of square kilometers. We can produce there some algae to capture more carbon, produce there some crops that we can capture more carbon, and all this space that is this green space, this. And now he's very narrow, but if you think that it at the bottom is 3.5 square kilometers, that is a lot of space. Or we can bring their solar panels, because it's a place with a lot of solar power potential. I agree with the idea of combination and studying of about the alternatives that we have. But yes, we need a simulation and a final counting of the carbon footprint. And there is no any other question, I think. I want to tell you that this adventure is very funny, very interesting. This is Engineers for a Sustainable World, and I can tell you that I am not even an engineer. I'm a lawyer, and I studied laws in Mexico for 7 years. In a law school, a master of or corporate laws. But my passion is energy, and I figured out since I was in the law school. But I like laws, and I'm still working as a lawyer. And I took my chances. I look for a university that allows people that were not engineers to study a Master of Energy program. And there was only a few options. One of them is the University of Auckland. The other option was the University of Hobart, and a very small amount of other university allows you to do that. And I had in advance a proposition of this project, but I need the master to check with my teachers and to check with other engineers if this was possible. I changed the idea a lot of time during the master, and at the end, I got the prize, the award of the best thesis of the. That is something that why I am telling you that, because sometimes we think, oh, it's not my area, or I cannot do more, and that is not true. Even that your background is different, even that your strategy in your life is different, you can always think about uh, bringing solutions to this world, and the engineering is a tool. It's very useful. I had a very hard time remembering all the calculus and all the stuff in the first semesters, but I did that. Also to adapting myself into another country, in another language, another way of life. Uh, but at the end, it is good for everyone. I don't care if in the future another people brings another invention better than mine. The thing is that we need a competition of minds in order to help this planet, in order to help the things going better always. And I think with this, I end my presentation. Thank you so much. Don't let your dreams in the bed. Bring them every day. And I want to be grateful with my wife because she always believed in me. She told me, take your chances, Daniel. Go for the scholarship. Go for the for go to the uni. She's also a lawyer, but she told me, I know that you can think out of the box and you can do that this stuff. I am so grateful with all my family, with my daughter, with my friends, my co-workers of my law firm in Mexico, because they always support me, with a friend of mine that it was my mentor, and I am here. I am happy. Thank you so much.
That was beautiful. We're so glad you took the chance so that you could give this amazing presentation to us today. Please join me in saying thank you, muchísimas gracias to Mr. Ramirez for the presentation. And if you want to hear more about renewable energy and New Zealand, someone who actually Daniel knows is giving a presentation tomorrow that I'm moderating. Anna and Vanessa, called Costa Rica and Iceland's Energy Models, Lessons for New Zealand in its Quest for 100% Renewable Energy. So if you want to keep on the same track there and theme, join us for that as well.
Thank you so
Thank you
much.
so much.